In this lesson, we are going to use ESP32 with ESP32 extension board from SunFounder to use NTC to measure the temperature and resistance of this and display it on the screen. And in the second project, we are going to display the temperature as Celsius and Fahrenheit on the LCD screen. And we are going to test it on the LCD2004 with 20 characters and 4 lines. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. Come to this page, docs.sunfounder.com, scroll down until you see ESP32, then click on ESP32 Starter Kit Main. On the left side, click on Arduino User, and scroll down 5.10 thermometer. This is our documentation page for today's lesson, and we are going to learn about NTC. We are going to use NTC to measure the resistance of the NTC and convert it with a formula to get the temperature. For this lesson, we are going to use ESP32 module. We will use ESP32 camera extension board. We are going to use a breadboard, jumper wires. There is a 10 kilo ohm resistor and our thermistor. If I click on the thermistor here, it has been explained. On the thermistor we see 103, and here it says 103. I hope you can see it. So this 3 means 30. This 0 is 0, so 1, 0 and 30, 10,000 or 10 kilo ohm. And this is NTC or negative temperature coefficient. This is a symbol and schematics. The NTC's resistance will decrease as the temperature rises. So the higher the temperature, the lower the resistance, so it will allow a lot of current to pass and lower voltage across it. Because we are not using PTC, I'm not going to talk about it, but this is the opposite. And PTC is usually used as a resettable fuse, and the resistance is increasing as the temperature increases, so this can block some kind of malfunction. And to find the resistance, this is a formula, and everything have been explained. I'm going to show you the formula that is used in the code, so it will be very easy. And then here is a suggestion that we could use one of these pins. We are going to use pin 35. And this is a schematic. We are using 10 kilo ohm resistor connected to 3.3 volts. And with this 10 kilo ohm resistor, we are using our thermistor in series. The other side of thermistor is connected to the ground. And this 3.3 volts will be divided proportionally to the amount of resistance. So this 10 kilo ohm get portion of this 3.3 volts, and the remaining will be here. If this is 10 kilo ohm and this is 10 kilo ohm equal, then the voltage will be split into two. The voltage will be divided by 2 equally. But this depends on temperature. As the temperature increases, this will be decreased. So the lower the resistance, and it means higher the temperature. Here is the actual wiring, which I'm going to show you in the wiring section. This is our code, which I'm going to explain it fully in the code explanation section. And here there have been some explanation repeated again. So this is our basic code 5.10. As you can see, this will just print temperature in Celsius. And this is the code for the LCD, which I am going to show you as well, and we are going to display it. When you use ESP32 with SunFounder's ESP32 camera extension module like this, it comes also with a battery on the package, and it comes a built-in charger, so you can connect it and charge it and disconnect, and later on you can use it with a lot of power, so you can power up your application very easily. And here's the wiring. You can use this ESP32 without the extension board from SunFounder and connect the female connector to this. But I'm going to use this extension board, which makes it very easy. Now let's do the wiring. Get the NTC. This does not have any polarity, so you can insert it in 2 lines like that anywhere. And then get the 10 kilo ohm resistor. Make sure this is 10 kilo ohm, otherwise you will not get the value properly. This is from DG Key. You can come here and go to 5 band, because we are using 5 band resistor. At the bottom just type 10,000, and these are the value, and here select the tolerance 1%. So it's brown, black, black, red, and then the tolerance is plus minus 1. So insert it to the right pin and then connect it as shown here in the red line, somewhere beside the red line. So I'm connecting it in here. From this resistor we get a wire, and it is connected to 3.3 volts. Red wire, I'm connecting it anywhere on this red. This is done. From the left side of thermistor, get a black wire connected to the ground. I'm connecting black wire here and connecting it to this point, and my black wire is connected to the ESP32 when the USB is this side. Second pin is ground, second pin is ground, or you can connect it on the terminal. I'm connecting it here so it doesn't get out. And this red was connected to 3.3 volts, and I've connected it also here to 3.3 volts. Now get a blue wire from the line where resistor and thermistor is connected, and connect it to pin 35. Here I'm connecting this blue wire and here, and this side is connected to pin 35. This is the 4th pin, and you can connect it also to the 4th pin in here. If you don't want to use that board, you can connect all the wires directly to these pins. Just use female connector to connect them. I'm opening Arduino IDE. Let's open our project by clicking on File, Open. On the left side, click on Downloads, then ESP32 Starter Kit Main on the right side. Double click to open it, double click on C, double click on Codes, and then scroll down until you see 5.10. Double click, thermistor, and then select the file, click Open to open it. So we start from the top. We are defining a pin for our thermistor, pin 35 of integer, and then we set our reference voltage 3.3 volts. This is greatly affecting our result if the voltage of the microcontroller is not exactly 3.3 volts. And then we have a reference resistor. This is the extra resistor. That is this resistor we are using to divide the voltage. And then the beta is a typical value for this calculation, a constant. And then we are using nominal temperature 35 degrees. This is the room temperature, but we can set it. So this is also affecting our calculation. And then nominal resistance of the NTC. So our NTC is 103, so that 3 means these 3 zeros. So we have a reference resistor and nominal resistance for the, so all these constant cannot change. Inside the setup, which runs only these 2 lines, we are using serial.begin and set the serial monitor with 115,200, and then using pen mode, we are setting the thermistor pen as input so we can read it. And inside the loop, which will run from here to here continuously. So first we use analog read and read the value from thermistor pin, which is analog to digital converter. This value is from 0 to 4095, which we have explained it in previous lesson, and the result is stored in a variable called ADC. This line gets the actual voltage, so we are getting ADC, multiplying it by this reference voltage, which is 3.3 volts, and then divided by 4095, so we can get the actual voltage. Now, from this voltage, we can calculate the resistance. And here is the formula for the resistance. This we get voltage times by reference resistor divided by reference resistor minus voltage. Here, the voltage is ADC value multiplied by reference voltage divided by 4095, so we get the voltage. And for the resistance, ADC value multiplied by reference voltage divided by reference voltage minus voltage, the actual voltage. This voltage is here, so we can get the resistance. Then we need to get the temperature in Kelvin. This is the formula. We are using the resistance, nominal resistance, beta value, and nominal temperature, and this is the absolute zero, and here that K is like this, 1 over log of resistance divided by nominal resistance divided by beta, this plus this value, 1 over nominal temperature plus absolute temperature, absolute zero value. So this will give us the K. Now to understand it better, because we have the nominal temperature 25 and we have nominal resistance and beta, then our formula becomes 1 over this 10,000 and 3095 for the beta, and this portion, if we do the calculation, it will be this value. So this is our formula. All the value is here except the resistance, which will change depending on the temperature, and we will calculate the Kelvin value. Once we get the Kelvin value, we can get temperature in Celsius. Kelvin plus minus 375.15. This will give us the temperature in Celsius, and to convert it to Fahrenheit, 1 times 1.8 multiplied by the Celsius plus 32, so this will give us the Fahrenheit, and this line is just printing it. It uses printf, so this is printing the temperature with 2 decimal point. The C is, this 2 means 2 and F means formatted, so this is formatting it and it's placing C and then new line, and then this line is printing again the Fahrenheit, and we have 300 millisecond delay, and the loop comes and does all these tasks over again to measure the temperature. Now let's see how we can select the ESP32 board. We can click here under the select board and type here ESP32 DEV. As soon as you type dev, you will see dev board. You can select it and click OK. So the board has been selected. Now we have to select the port. The other way to select the board is click on Tools, Board, ESP32, and select the ESP32 dev module. Now we have to select the port. If I click here, it shows 2 ports, and I don't know which one belongs to my device. Sometimes you will not see the number properly. So the best way to be sure, right click on the Start menu, go to the Device Manager, and you will see here the ports. If I click on this arrow, it will show me the ports. One is USB serial CH340, the other is USB serial device. And here, now it's connected. If I disconnect this, one of them disappears. The one that disappeared is my board. So 6 stays and 8 disappeared. If I connect it, so 8 is my COM port, CH340. Now 8 is my COM port and I can select it. Or I can click on Tool, Port, and here you will see it. You can select whichever you want. Ours is COM8. Now we have successfully selected the board and the port. And this is very important. It must be done first. Now let's just click on this icon to upload it to our board. The code will be uploaded. So this is done. Now let's open the serial monitor. If I click here, we will see the value. It's printing, but before that, let me show you some important fact here. We have defined the serial monitor with 115,200. This number here must match. If you have something like 9,600 or different value, you will not be able to read. This will be a non-readable text. So make sure that it matches the value that we have selected there, 115,200. And here now it shows around 26 degrees. If I hold it with my hand, you will see the temperature is increasing, 30 degrees and higher, 32, 33, 34 even. 35 degrees, and also in Fahrenheit. Now I'm using this heat gun to heat it up. So let's see, 50 degrees. I have to make sure it doesn't burn it. 60, 70. So you got the idea that this is measuring the temperature. Now it will cool down back from 80 degrees. It goes back, cooling down. If I hold it with my hand, maybe it will cool down quickly. Yes. So this was the demonstration. And now let's do the wiring for the LCD. Now we're getting 4 male to female wires like this. I'm just connecting them like that. And if I turn this around, we will see the value SDA and SCL. We'll connect the white wire to the ground, which is the second pin from the top. And then we are connecting the gray wire to 5 volts. And here you see that's the first pin. And then SDA, this is the purple wire. We're getting it and connecting it to pin 21 and here. And then we look at the SCL, the blue, goes to pin 22 and here. That's the fourth pin. And then find 5.10 thermistor LCD. Double click to open it. 5.10 thermistor LCD selected. Click open. And this is our code for thermistor and LCD. We have already used this before. The wire is for I2C communication. We are including the library. I have shown you how to include this library, but quickly, to get the library quickly, let me show you. I have already explained it. Right click, copy this name, paste it here and remove the underscore, and you will see that this library by Frank de Barbander. So select, click install here. I have already installed it. You will see a button like this. Click to install and click here. So you will exit. If you don't install this, it will not work. And then from this class, which is here, we from an instance of the class, we create an object called LCD, and we enter the I2C address. I've explained it in the LCD video. Please watch that. 16 is number of characters, and 2 means 2 line. And these are all the constants that I've just explained in the previous code. First, we clear inside the setup, clear the screen from previous value, initiate the LCD, and LCD.backlight, it will turn it on, and this was the same as before. Inside the loop, this portion up to here is exactly the same, nothing is different. And here we use LCD set cursor, and this has been commented out, so this does not print anything on the serial monitor. We are setting the cursor at character 0, line 0, and printing this text temp, and printing the temperature with 1 decimal point. Then we are printing LCD write 233. This is printing the degree symbol, and we print C. Then we go to the next line. This portion is for the next line. We go to character 0, line 1. This was line 0, and this is line 1. And we print this text temp, and we print temperature in Fahrenheit with 1 decimal place. And then LCD print, again the symbol, and then F. This was just printing C, and we have 300 milliseconds. And the code will run back from here and does all these things over again. Now let's upload the code. Click. Wait for it to get uploaded. And here we can read the temperature in Celsius and Fahrenheit. If I hold it with my hand, with my fingers, the temperature is increasing, 32, 33, and so forth. Let me get the heat gun and apply some heat. The temperature is increasing. $73. And let me connect this 4-line 20-character LCD. It has the same I2C address. And press this reset button if you read strange characters. So reset button, so you can read the actual value properly. And this is without changing anything in the code or wiring or anything. I just connected it. When you use the extension board from SunFounder, it comes with a battery and battery charger built in. This is a lithium 18650 battery, which lasts very long, and you can chip it continuously without connecting to USB. You can use and test your project. As I mentioned before, green looks always better in this LCD. Now I'm going to bring the blue below the screen. So just compare these two now and see which one is better. Definitely green looks always better. And I would suggest if you can buy separate LCD, get the green one.